of our last chapter, Chapter 11 on probability. So our first concept is sample spaces. A probability experiment is an action or trial that has varying results, such as flipping a coin, rolling a die, spinning a spinner. The possible results are outcomes. Okay, so when you flip a coin, heads or tails, those are the outcomes. For instance, when you roll a six-sided die, you can get a 1, 2, 3, 4, 5, or 6. Those are outcomes. Now, a collection of one or more outcomes is an event, such as rolling an odd number. The set of all possible outcomes is called the sample space. So for flipping a coin, sample space is heads or tails. Example 1. You flip a coin and roll a six-sided die. How many possible outcomes are there in the sample space? List all the possible outcomes. So you can do this vertically or horizontally. So what we're going to do is we're going to make one of those trees, a tree diagram. So first off, I'm going to have my coin flip, and that's heads or tails. And then I'm going to have my roll the dice. So my first event, my first thing I do, my first experiment is flip a coin. I get heads or tails. Those are my possible outcomes. But then I can get a 1, a 2, 3, 4, 5, 6. And on the tails, I get a 1, 2, 3, 4, 5, 6. And this isn't hard, it's just tedious. Okay? So the sample space, and usually we put that in braces, would be, and you can list this any way you want. You can do 1H or H1, and then H2, H3, and so you see where this is going. Tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Okay, that's the sample space. Those are all the possible outcomes. Now remember, if I just rolled a die, my sample space would be 1, 2, 3, 4, 5, 6. If I flipped a coin, it's just H or T. But since I'm combining them, these are all my possible outcomes in the sample space. All right, now we have theoretical probabilities. So the probability of an event, the chance it will happen, the likelihood that it will occur, you have between 0 and 1, including 0 and 1. Okay? And you can do that as a decimal, fraction, or percent. So if there's no chance of it happening, okay, like today is, let's say, Thursday. Tomorrow, what's the chance of tomorrow being Monday? There's no chance. Tomorrow's going to be Friday. So there's a 0 or a 0% chance. Now, if I say, when you look at the weather, that's where this comes in. How likely is it to rain today or tomorrow? You could have anywhere along the spectrum of, 0 to 1. And you'll see sometimes there's a 100% chance of rain today. There's a 50% chance of rain. There's a 90% chance. Okay? So anywhere along the spectrum, you can have probability. And it can be a fraction, whole number, decimal, percent. All right, student taking quiz randomly guesses the answers to 4 true-false questions. What's the probability they'll guess exactly 2 correct? So again, this is not difficult. This is just time-consuming and tedious. So let's make a table of correct. Okay? So if there's 4 questions, you could have 0, 1, 2, 3, or 4. All right? So if you got 0 correct, then that would be wrong on the first, second, third, and fourth. Let's say, and again, you're just guessing here. So let's say you got the first one right, and then 1, 2, 3 wrong. Okay? And this is just one right. So you could have also gotten the first one wrong, the second right, the third one right, or you could have gotten the last one right. Those are all the ways of getting one correct. Now, two correct. You could have had the first two wrong and the last two right. You could have every other one. You could have the middle two right. You could have the middle two wrong. I'm running out of space here. You could have every other one, but starting with right. And you could have the first two right and the last two wrong. Okay? So, how many choices are there? There's 1, 2, 3, 4, 5, 6. Okay? Now, you might think we can stop now. Unfortunately, we can't because we need to find out how many are there total. But this is easy at this point because 3 is just going to be the mirror image of 1. So, X, yes, yes, yes. Yes, no, yes, 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 and so forth. So, this is going to be the mirror image, and so there's going to be the same number of possibilities. So, how many we have here? We have 1, we have 4, we have 6, we have 4, and of course this one would be yes, 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 yes. So that would be 1. So if you add those all up, there's 16 possible outcomes. So what's the probability? Well, I'm looking at 6 outcomes out of 16 outcomes, which we can reduce to 3 out of 8, but probability is the one place in math you don't have to reduce. So either one of those is correct. Also 0.375 and also 37.5%. All right, so here is a new core concept. The probability of the complement of an event is 1 minus the probability of the event. So in other words, what's the other percent chance of it not happening? Would be 1 minus the percent of it happening. Okay, this will make more sense here in a second. When two-sided dice are rolled, there are 36 possible outcomes. Okay? Anywhere from 2 down here to 12. All right? Now, what's the probability of a sum not being 6? So here's the thing. You have two choices here. You can count up all the ways of not 6 and just get the answer, or you can just find out the probability of 6 and subtract. That's going to be quicker. Okay? So you look for 6. So that's going to be 2 and 4, and then 5 and 1, and 3 and 3, and 4 and 2, and 1 and 5. Okay? Now yes, 5 and 1 and 1 and 5 are both add up to 6, but that's why we have different colored dice, because 5 on the white, 1 on the red is a different roll than 1 on the white, 5 on the red. So how many possibilities are there to get 6? 1, 2, 3, 4, 5. 5 out of 36, and that's to get 6. But we're looking for not 6. So that would be 1, sorry, I meant to write minus, I didn't, 1 minus 5 over 36. Okay, and that's basically going to be 31 over 36, or 0.861, or 86.1%. Okay? So there's 36 chances, and 5 of them are the ones you don't want, then 31's the other, the complement. The sum is less than or equal to 9. Okay? So less than or equal to 9. So we have 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. That's okay. We can do 9. And you can see this is taking a long time to find all the ones that are less than or equal to 9. And we can do that. Or using the concept of the complement, we can find the greater than 9 and just go backwards. Again, I want you to see you have a choice, but the quicker way will be to go backwards because there's going to be less of that. So we have 12, 11, 10. Okay? And then here we have 11, and here we have 10. And here we have 10. That's 1, 2, 3, 4, 5, 6. There's 6 ways out of 36 that we don't want. So that leaves 30 out of 36 that we did want. And that's 0.833 or 83.3%. So I want you to see that you can go either direction. It's up to you. One's just going to be more time consuming. Okay, probabilities. Probability is based on repeated trials of a probability experiment. So continuously flipping coins, continuously rolling the die, continuously doing the spinner. The number of trials is the number of times the experiment is performed. Okay, so if you roll 7 times, if you spin 12 times, that goes on the bottom. Each trial that is favorable that we're looking for is a success. The experimental probability can be found using this setup. Number of successes, number of trials. Think about a test. If you took a 75-point test and you got 72 of them, 72 were successful. Okay? And you can write that as a fraction or a decimal or a percent. Okay, so each section of the spinner has the same area. Okay, equally 1/4 each. The spinner was spun 20 times. The table shows the results for the color of the probability stopping on that color. Okay? So here's what we got. 5 red, 9 green, 3 blue, and 3 yellow. So to find the probability, we just use a big P and we put red here. Okay? Well, the probability of red, how many reds are there? 5. Out of how many times did we spin? 20. Okay? The probability, that's supposed to be a P, of green. Well, that's 9 out of 20. Probability of blue, that's 3 out of 20. And the probability of yellow is also 3 out of 20. Now, here's the thing. We can also do this as percent or decimal. So this is 0.25 or 25%. 9 divided by 20 is 0.45 or 45%. And 3 divided by 20 is 0.15. I don't know why I just drew that line. Or 15%. And obviously this has the same because they're both 3. Okay, don't know why that popped up. All right, now the last question is, for which color is the probability the same? Well, that would be blue and yellow. Are both 3 out of 20 or 15%. Okay, and now on to our last example. In the U.S., a survey of 2184 adults 18 over found that 1328 of them have at least one pet. Types of pets these adults have are shown below. What's the probability that a pet-owning adult chosen at random has a dog? many have a dog? 916. All right. Now, how many people were there total that had pets? 1328. Not this, okay, because that's just how many people we're surveying. We want the people who have pets. That's what we're talking about. So you got to be careful. Sometimes there's extra numbers thrown in. So there's our fraction, which is equal to 0.69 or 69%. So if you just randomly chose one, there's a 69% chance that you're going to get a dog owner. That's it.